Hello, my babies. It is Miss Lloyd, and we are looking at polynomial functions. So when we're looking at polynomial graphs, they do have a continuousness. So when I say this, I'm talking about like, well, we may have some ups and downs in life, but it continues on, meaning it doesn't have any breaks. And by breaks, I mean like, okay, we started off the function, and then actually this wasn't happening here. It kind of stopped for a moment and then continued on over this way. So it doesn't have any breaks like this. It's just continuous, nice, flowing, kind of like something you would ride a roller coaster with. If you look at it and you're like, I would not want to ride that roller coaster. That is how I would die. It's probably not a function. So they have smooth, rounded turns instead of really sharp turns. So when we see things kind of like our absolute value function that have this very, very sharp turn, again, you don't want to ride that roller coaster. If it comes at a turn like that, there's no way that like you're just gonna crash. Like, if this is your roller coaster, and then here's all the people on it, they're raising their hands. Ah! Like, you don't have enough time to actually, like, swoop down and turn into. So it has these breaks in it, or it has a little point there, and it's just not very, roller coastery. So polynomials are like roller coasters. If it doesn't look like a roller coaster you'd want to be on, then probably is not a polynomial. So when we're talking about the leading coefficient test, when we have an exponent that is odd, so our highest exponent is odd, and our leading coefficient is positive. So first off, when it's odd, it means that the ends are going in opposite directions. So odd and opposite, that's how I remember it. So if it's positive, then that means that your whatever is your furthest right um, arrow, so um, the furthest right that you can go on your function, it's going to be going up if it's positive, it's going to be going down if it's negative. So here we have it going up, and whenever our leading coefficient is negative, our furthest right is going down. So in this case, when it's odd and positive, it's going down to up. So reading left to right, ultimately it's going to be going up. So our function is going up towards positive infinity as our x value is also going to positive infinity. So if I had an x and y axis here. As our x value is going towards positive infinity, our y value is going towards positive infinity. As we are going towards negative infinity, we're going down. So we're going down to negative infinity on our y-axis. When it comes to the opposite situation, so we have a leading coefficient that is negative, so we're going up to down. As we are looking over towards negative infinity, it looks like we're going up to positive infinity. And as we're looking at positive infinity on our x-axis, we're going down towards negative infinity. So as I'm going to the right, the function is going down. When we have an exponent that is even, so our highest exponent is 2, 4, 6, 8, any of those kinds of numbers, then the ends are going to be going in the same direction. So we're either pointing up or we're pointing down. So when we're positive, it's all going to be pointing up. So no matter if you're looking at positive or negative for your x, so as we're going to the left, we're going up towards positive infinity. And as we're going to the right, we're still going up towards positive infinity. If we start our day negative, then everything's kind of going to be going downhill. And so if our leading coefficient is negative, then everything's going to be going down. So as I'm looking towards the left, my arrow is going down, so towards negative infinity. And as I'm going towards positive infinity or towards the right on my x-axis, I'm still going down. So down towards negative infinity on the y-axis. So we want to describe the left and right hand behaviors of the graph for each of the functions. So we're trying to figure out, okay, as we're going one direction on the x, what's happening with the y value? So first thing I like to look at is the highest exponent. In this case, I have a 3, so I know that my exponent is odd. So if my exponent is odd, I know that the left and right-handed behavior is going to be going in opposite directions if it's odd. So it's either going to be going up to down or down to up. I then look at my leading coefficient to figure out which directions those are going. So my leading coefficient here is a positive number. So because it's positive, I know that I'm going to be going up. So my last arrow, or the arrow to the right, is going to be going up. Because it's odd, they have to go in opposite directions, so it's down to up. So if my left-hand behavior is going down, that means that as I'm going to the left, so as my x is going to negative infinity, the arrow is going down. And so that means I'm going down on my y-axis to negative infinity. And typically we have this in the opposite order. So then the other behavior, as it's going up, or as I'm going to the right, so as my x is going to positive infinity, the arrow is going up. So my f of x, or my y values, are going towards positive infinity. And that's all we got to look for. So in this next one, again, I want to look at my exponent first. Here my exponent is 5, so it's odd. Because it's odd, I know it's going to be going in opposite directions. And my leading coefficient is negative 3.6. It doesn't matter if it's a decimal or a fraction or a whole number. It doesn't matter if it's pretty or kind of gross. We're just looking at whether it's positive or negative. So my leading coefficient here is negative, which means I'm going from up to down. So my right hand, your leading coefficient tells you what direction that right hand is going to be going. The odd, or the exponent, tells you what the left one is going to do. So either it's odd and it's going to be going the opposite direction as the right hand, or it's even and it's going to be going the same direction as the right hand. So since we've got negative, this is up to down. So then if I'm starting up, so as I'm going over to the left, so as my x is approaching negative infinity, we're going up. So my y value is going to positive infinity. And then as I'm going over to the right, so where my x value is positive infinity, my arrow is going down. So it's going down towards negative infinity. Next thing we're going to look at when it comes to polynomials, one of the things that we tend to look at the most is our zeros, or our solutions, our factors, or x-intercepts. Those are all the exact same thing. They can be written in a few different ways. So factors we always see as the parentheses, and they're typically multiplying with something else in order to create the polynomial. Our zeros and solutions tend to look the same. They're always x equal to something. And then our x-intercepts, so we know it's where we're intercepting or crossing the x-axis. It's always going to be some x value, comma 0, because our y value is always going to be 0 whenever we're crossing the x-axis. So here, for this first one, they want us to find all the zeros of this function and then determine the maximum possible number of turning points for the graph of the function. So here I know that the possible zeros, or the number of possible zeros that I have, is 3, because that's my highest exponent. So I have a feeling that I should have at least 3 numbers. Maybe I'll have a double root, so one number twice. I know that's where it's going to be bouncing off, or I could have 3 solid numbers where it's going all the way through. So then also, I don't have to graph the actual function. I made a little graph off to the side because I'm a visual person, and so it kind of makes more sense to me if I see where everything is going to be, if I see where my zeros are, I can see how many turning points I have. So like for this first one, I have 3 places where I'm crossing the x-axis, and I have a turning point here, so I was going up to down, and I have another turning point here where I'm going down to up. So there's 2 turning points because I'm crossing that axis 3 different times. So then this one, I have to find all the zeros first. So I know the zeros are the same as solutions. They're the same as our x-intercepts. So I know that I'm basically putting my y value as 0. And then I'm going to be solving. So this is where all of our factoring skills come into play. When I'm trying to solve or I'm trying to factor something, I always look at my GCFs first. And it looks like everything has an x in common. So I'm going to take that out and put it up to the front. Now I have a quadratic trinomial that I need to break up, which means I could try to use my M&A method. So I'd be multiplying to get 36 and adding to get negative 12. So the only numbers that would multiply to give me positive 36 and add to give me negative 12 are going to be negative 6 and negative 6. The negatives, when we multiply them together, will give us a positive, and if someone owes you $6 and then they borrow another 6, they now owe you 12. So they're in debt 12, negative 12. So my factors here, because I don't have a number or a leading coefficient greater than 1 in front of my x squared, I know that I can just use a shortcut method. So x minus 6 and x minus 6 are my factors. I'm not going to forget about the x that I originally took out. From here, because everything is multiplying, I can use a multiplicative property of 0, meaning everything is set equal to 0. And then I need to solve. So I technically have three solutions, even though one of them is twice. I have an x equal to 0, and I have x equal to 6 twice. So what happens when I have x equal to 6 twice? This is a part where we're touching the x-axis and bouncing off. So then on my graph, I know that I'm crossing at 0, 0 and at 6, 0. I know that this is positive and it's odd, so that means we're going to be going down to up. So that means I would be going from down to up through my 0, and then I would have to be bouncing off of 6 and going back up. Anytime we have a double root, it means we're not completely crossing through the x-axis, but we're touching it and bouncing off. So in order for this to work, I don't know where this maximum would be. It could be over here. It could be way up higher. We don't really know, but we know there has to be a turning point up here, and I've kind of already made a turning point there. The rest of the graph is kind of unknown to us unless we were to plug some numbers into a t-chart and find it out ourselves, but that's not really what they're asking for. They're asking for all of our zeros. So I know my zeros, I have one at 0 and I have a double root at 6. So you could write that twice, you don't have to. You could just write it once. If I just write it once, I put off to the side that it was a double root. And that means we have to have at least 2 turning points. So my maximum here, or at most 2 turning points. I would have a maximum somewhere in there where I'm turning so that I could go from 0 to the 6, and the 6 bounces off, so that's where one of the turning points is. So they've asked me to find the zeros. I did that. Then they wanted me to determine the maximum number of turning points, and I've done that, so we're ready for the next bit. So our intermediate value theorem. If we have a function and say we've plugged in a and we get this number, and then we plug in b and we get this other number, then technically there is bound to be a point in between the two. So we can have a point here where we plug in c and we get some f of c value. So there's always some value in between all of these other values. So when we're sketching a graph of our polynomial function, what I like to do first is find my zeros. So I know if I figure out where my zeros are, I can find some points that are in between. If I have zeros somewhere, there have to be points in between, so I can plug in some nice numbers that are in the middle of it and get a better idea of what this graph looks like. So when I'm finding my zeros, that means I'm setting the function equal to 0, trying to do some factoring, and getting the x's by themselves. So here, whenever I did my solving, trying to figure out my zeros, I ended up with a 0. Whenever I take the square root of 0, technically this is a double root. When we take the square root, we typically have a plus minus. I can't really have plus minus 0 because 0 isn't positive or negative, but this is going to be a place where it bounces, touches the 0 and bounces off. So touches the x-axis and bounces off. And then I have a solid 3. So now that I know of at least 2 points, I'm going to make up a t-chart. And in my t-chart, I know that I have a point at 0, 0, and I have a point at 3, 0. So it's a really good place to start. And I want to figure out what my graph looks like around these zeros. So I'm going to plug in a point below, and then some points in between, and a point on the other side. So I want to get a good idea of what's happening around these zeros. You can plug in more than just those numbers. I could plug in -2 as well, or maybe 5, maybe 1.5. But this is all that I really think is necessary, and these are easier numbers to plug in. So when I say plug in, I mean to the original function. So when I plug in -1, I end up with a y value of -8. We already plugged in 0, and that would have gotten us 0 because 0 is a 0. It is a solution. It's one of our x-intercepts. And we do the same thing for the rest. So now that I have a bunch of points, I'm going to put these on my graph and draw my curve. My very important points, my zeros. And I know that this is an odd function that starts off positive. So we should be going from down to up. And it looks like I'm starting off at -1, -8. I would be going up to my 0, and we said it was a double root before, so it makes sense that when I have +1, I end up with -4 because I'm going to be bouncing off that 0 and going the opposite direction. It looks like I'm also at -8 again. And then I would be going back up to my 0 that was 3. So my solution that was a positive 3. And then my 4 is at 32, which is way off my graph, so I'm just going to have it go up pretty far and not cross number 4 yet. So we can see that it's going down to up because it was positive, leading coefficient, and an odd exponent, and we have where we're crossing our x-axis. Next one, again, we're going to find all of our zeros first. One thing that I really don't like about this are the fractions, so I'm going to get rid of those right off the bat and multiply everything by a 4. Then I'm going to get on with my greatest common factor that I can take out of everything. I like for my first, my leading coefficient to be positive, so if it's negative, I take out a negative. And from here, I've got a quadratic trinomial, so I can do my M&A. All right, so I've got my zeros. I've got 2 double roots, so I have 2 places where we're bouncing off the x-axis. So I have it at 0 and at positive 3, and these are also great places to start when it comes to making my t-chart. So I'll throw in some numbers around my 0 so I get an idea of what's happening. And so these are numbers that I'm plugging into the original function, which hopefully you've got a calculator on hand because this is going to get pretty messy. Now, whenever I make my t-chart, I do end up with 2 y values that are exactly the same. So it's not likely that we have a straight line going through there. It's likely there's a minimum point or a maximum point somewhere in between here. So we'll kind of see how this goes off. This is an even exponent, so I know the arrows are going to be going in the same direction. Our ends are going to be going in the same direction. Because our leading coefficient is negative, they're both going to be pointing down. So I'm going negative 1, 1, 2, 3, negative 4. Got my negative 1s in there, and then negative 4 again. So I know that I'm starting down, going up, we're touching and bouncing off. It's likely that's not going to be a straight line, touching and bouncing off again, and then going down. And there we go. So then our last bit that we're going to go over, say we're given zeros, we're given solutions, and they want us to find the polynomial that this goes with. So remember, whenever it comes to solutions, we're basically saying that all of these things are equal to x. X is equal to all of these things. So I know x is equal to 0 and a half and 3, and then positive and negative square root 2. I'm going to put those together because I know in order to have gotten the plus minus, positive, negative, that means I would have had to take a square root. They also have a square root, so I know here in order to undo that square root, I would just square. Typically when we have a plus minus like that, we have the solution together to begin with, and then we separate it into the two. So I've set all of my zeros equal to x. Now I'm going to set all of these equal to 0 because I know that in order to get my solutions, I had set my factors equal to 0, so I'm undoing or going backwards from finding the zeros. Now I have the zeros and I'm going to find the polynomials. Here, I don't like fractions, so I'm always going to multiply that first. So I've got 2x minus 1 as one of my factors. The x is already equal to 0, so I'm not going to worry about it. I've got x minus 3 as my next factor. And again, in order to get rid of that square root, I would square both sides. That's also going to eliminate the plus minus. It's not necessary anymore. So I've just got 2. So x squared minus 2 is going to be my last factor. So then the last thing we need to do, in order to have been able to set all these things equal to 0, they had to have been multiplying and equal to 0. So I'm going to multiply all of my factors together and have it equal to 0 to figure out my polynomial. So I'm going to have to do a lot of distribution. I'm going to fast forward through a lot of this. You can always pause or have YouTube slow it down for you if you need it. And then we're done. We don't have any more like terms to combine. Everything's been multiplied out. So this is the beautiful polynomial that would give us those 1, 2, 3, 4, 5 solutions. We did have 5 solutions, and we have x to the 5th power. So that helps us make a little bit more sense of it. I hope you guys had a wonderful time with me today going through these polynomials. If you did, please hit like or subscribe or both. If you think that there is someone who could use this, please feel free to share. Spread the love.